JWST just confirmed something the universe wasn't supposed to contain. For 3 years, astronomers stared at strange compact red dots scattered across the deepest images James Webb had ever taken. Tiny. Faint. Crimson. They appeared in survey after survey, in pieces of sky that should have shown only the oldest, dimmest galaxies in existence. Nobody knew what they were. Some thought they were ancient star clusters. Others suspected dusty galaxies wrapped in their own light. The community even gave them a placeholder name. The Little Red Dots. In May of 2026, the Chandra X-ray Observatory turned its instruments on a sample of these objects. And what came back broke a model of the universe that had stood for 2 decades. The dots were not galaxies. They were supermassive black holes. Visible only because of the X-ray glow from matter being torn apart at their event horizons. And the light reaching Earth had been traveling for 11.8 billion years. Stop and consider that number. The universe is 14 billion years old. The light we see from these objects left them when the cosmos was less than 700 million years old. Less than 5% of its current age. A baby universe, still cooling, still assembling its first structures. And inside that infant cosmos, fully formed supermassive black holes were already feasting. Each one has the mass of 10 to 100 million suns. To put that in scale, the black hole at the center of our own Milky Way, after 13 billion years of growth, is roughly 4 million solar masses. These ancient monsters were already 10 to 25 times larger than ours, when the universe itself was still in its infancy. Standard cosmology says this should be impossible. The accepted theory is called the seed black hole model. It works like this. The first generation of stars, called population 3 stars, formed from pure hydrogen and helium roughly 200 million years after the Big Bang. When those stars died, the largest collapsed into stellar mass black holes, around 100 solar masses each. Over the next billion years, those seeds were supposed to merge and accrete gas slowly, growing through gravitational mergers until they reached supermassive scale. The math has a hard limit. It is called the Eddington limit. A black hole can only swallow matter so fast before its own radiation pressure pushes incoming gas back outward. At the Eddington maximum, a 100 solar mass seed needs roughly 1 billion years to grow to 1 million solar masses. 2 billion years to reach 10 million. The little red dots are 10 to 100 million solar masses. At 700 million years post-Big Bang, the universe was not old enough to grow them. Not even close. This is not a small discrepancy. This is not a missing factor of 2. This is, by some estimates, a factor of 100 more growth than known physics allows. The seed model, which has anchored astrophysics textbooks for 20 years, cannot produce what we are seeing. So the field is now confronting 2 possibilities, both of them strange. Possibility 1. Direct collapse black holes. Instead of starting as stellar corpses, gas clouds in the early universe might have collapsed directly into massive black hole seeds, skipping the star phase entirely. These would have been born already at 100,000 solar masses. From that head start, growing to 100 million in 700 million years becomes feasible. The trouble is, direct collapse requires very specific conditions. Pristine gas, no metals, suppressed star formation. Conditions that should have been rare. Yet the little red dots are common in JWST surveys. Hundreds have been catalogued. So either direct collapse was far more frequent than we believed, or our criteria for it are wrong. Possibility 2. Super-Eddington accretion. Maybe the radiation pressure limit can be bypassed under early universe conditions. Some theorists argue that in the dense, low metallicity gas of the young cosmos, black holes could swallow matter at rates 10 or 20 times the classical Eddington limit. If so, our textbook ceiling on growth speed is simply wrong for that era. There is also a third option that is harder to talk about. Maybe the universe assembled faster than our cosmological clock says. Maybe the timeline from the Big Bang to structure formation is compressed compared to what the Standard Model predicts. That would mean rewriting not just black hole physics, but the expansion history of the universe itself. For now, no one knows which answer is correct. What we do know is that the little red dots are real, the X-ray conformations are unambiguous, and they exist in numbers no version of standard cosmology can explain. The universe was not supposed to contain these objects. And yet it does. Hundreds of them. 11.8 billion light-years away, glowing in X-rays, mocking our textbooks. JWST was built to look at the early universe. The expectation was that we would see fainter, simpler versions of what we see today. Instead, we found something the early universe should not have been capable of producing. Black holes too large, too soon, in a universe too young. The story is not finished. New observations are being scheduled. Models are being torn apart and rewritten. Some scientists believe the next decade will produce the most fundamental revision of cosmology since the discovery of dark energy. And it all started with a few faint red specks in an image. Specks so small that for years, no one was sure they mattered. Now we know they matter. They might be the loudest signal yet that the universe we thought we understood is hiding something we have not yet learned to see. This is Cosmic Report. The mystery is just beginning.